Hello, greetings. So this is science paper 2, which is chemistry, and this is a paper for 2024 internal candidates. I want you people to follow me clearly and attentively, even as I make this particular paper so simple. Like even as I get to teach, I'm also teaching you on strategies that you need to use even as you get to answer exam questions. I guess you are going to improve your understanding, and by the time we are done with this paper, you will discover that science is actually very simple, more especially chemistry. So will be answering section B. So section B, one word answer. Here it is saying answer all questions in this section. Write your answers in the spaces provided in this question paper. So these are the questions that I want us to start with. If you are not able to see clearly and you can't view these words, please turn your phone to be in landscape so that you are able to see. I dive into the questions. I guess you are well prepared. So the question is saying, state one importance of chemistry in our homes. We are taught to state one importance of chemistry. So you need to understand that chemistry is important in so many ways. And one of them is that you are going to observe that it helps us maintain what? So I'm going to say that helps get to maintain. So I'm going to say that helps maintain what? Cleanness. So I'll say cleanness. So I guess this is how we write cleanness, as well as what? As well as hygiene. So we can talk of hygiene like this. Hygiene, then I'll say etc. A lot of things get to be involved. And even when it comes to cooking, there is some chemistry that is there. So we can also involve what? I'll say cooking and what? So I'll say cooking and food preservation. Cooking and food what? Preservation. These are just short answers. Here we are just told to state only one importance. So you are only told to state one importance, and this is it. So helps maintain cleanness. So kindly confirm with me if this is the correct spelling. So cleanness, hygiene, etc. Also cooking and food preservation. You just pick one there. Then we go to 2. Describe one way of minimizing land degradation due to chemical industrial activities. So when it comes to one way in which we can minimize land degradation due to some chemicals that get to be present in the land, and it gets to bring about land pollution, all those things polluting the land. So state only one way in which we can do what we can deal with this. So you need to understand that one way is just the proper use of what. So I'll just say proper treatment of what. So I'm going to say that the proper treatment of what? Proper treatment of industrial. So proper treatment of industrial waste what? Waste of water. So waste of what? Waste of water as doing what? So we can consider as well as removing what? So I'm going to say removing what? Removing chemicals. So removing chemicals before discharging. So before what? Before discharging. This is it, and this is what you need to get. I guess you are able to follow clearly. We move now to B. B is telling us to say define Brownian motion. What is Brownian motion? You need to understand that whenever we are talking about Brownian motion, we are just talking about a random. So we get to define this as the random what? Random movement. So this is just defined as the random movement of particles. So where do they get to move now? So random movement of particles in what? In gases. So we get to consider gases and what? And liquids. So if I tell you what is Brownian motion, this is just the random movement of particles in gases and liquids. So this is it. We move now to this particular question that is here. This question is telling us to say, apply the kinetic theory of matter to explain evaporation as a change of state. So they want us to explain now evaporation as a change of state using kinetic theory of what? Kinetic theory of matter. So you are supposed to understand that when it comes to liquid evaporating, so there are certain things you need to understand. So I'll start, since I'm answering this particular paper, so I'll start by saying that when a liquid, so when liquid gain what? When liquid gain kinetic energy. So when the liquid gain kinetic energy, it will do what? They will vibrate. So I'm going to say that they vibrate, they start to vibrate rapidly. So they vibrate what? Rapidly with short distances. So with what? With short distances. So with short what? With short distances. So put a comma there, with short distances. Why are they doing this? So that they do what? They overcome. So I'm going to say that to do what? To overcome a certain force of attraction. To overcome force of what? Force of attraction. So I'm going to say to overcome a force of attraction. So they do what? So I'm going to say that so that they escape into the atmosphere. So that they get to escape into the what? Into the atmosphere. So into the atmosphere. So I'm going to say into the what? Into the atmosphere. This is what you are supposed to get. So this is just 2 marks. So you don't need to offload a lot of data here. This is just 2 marks, and this is how you are supposed to be answering these particular questions. We've answered this one. Let us now go to B2. Let us see how B2 is. B2 is here. This is B2. An interesting question. I guess you are able to see. Now, how can we answer these questions? The questions are saying the following symbols show nuclides of element X. You understand that an element is a pure substance. So even as I continue, please, if you've not followed us on this channel or page, please do so by subscribing and follow us. Share with your friends, and by the end of this, make sure you put that particular comment according to how you are understanding this particular lesson. This is XX. Have you seen? They are just the same. They are just different with what? They've got some different mass numbers. But proton, just the same. Now, they are telling us to say, what term is used to describe the 2 nuclides of element X? What term is used to describe the 2 nuclides of element X? Same proton, different what? Mass number. That is an isotope. So we just say isotopes. So these are what? Isotopes. We are done. Then we proceed to this one that is here, saying define the term you have mentioned in one above. So in A1 above, isotope, they are just telling us to explain what an isotope is. So what is an isotope? Just looking at these two, you are able to tell me that an isotope, you are going to say that these are what? These are atoms. So you say isotopes are what? Describe the term you've mentioned above. You start. So you start properly. You say isotopes. So nicely, isotopes are what? Isotopes are atoms. You say atoms of the what? Atoms of the same element. So atoms of the same what? Same element. Atoms of the same element with same. So with what? With the same proton number. With same what? Proton number. The other name for proton number is atomic number. So you can say same atomic number or proton number, but different what? But different mass number. But different mass number. This is it. Different mass number. This is how you are supposed to do it. So we are done with this one, and this is how we need to be answering. So the other name for mass number, this is neutron number. I don't want you people to be confused. We proceed now to B. This question that is here is saying, state the type of bonding that would be formed, have you seen, that would be formed between sodium and element X. You need to understand that sodium, this one is a metal, this one is a metal, yes. Then we go to element X. Element X, the proton number is what? Proton number, that is when we talk about 6. That is a 6. Have you seen? That is a 6. It is in group 4. Have you seen? To be specific, if you check the periodic table, this one, have you seen? It is in group 4 because there is 6 proton number. So electronic configuration, that is 2 and a 4. Have you seen 2 and a 4? So meaning it is in group what? It is in group 4. That is carbon. And carbon, we understand that that is a non-metal. So a type of bonding that gets to exist between a metal and a non-metal, that is called ionic bonding. So we just say ionic what? Ionic bonding. Another name for ionic bonding, we get to call this as electrovalent bonding. This is called what? Electrovalent bonding. So you can say ionic bonding or electrovalent bonding. These are the answers. I talked about these things. You need to understand that the number of electrons in the outermost shell will determine the group of that particular element. And the number of shells, 2 shells, determines the period. So group 4 period 2, because we only have 2 shells there. We are done with that. We now go to C. This question that is here. They are telling us to say, explain why most elements on the periodic table have mass numbers which are not O numbers. So they want you to explain why is it that most elements that are on the periodic table get to have a mass number which is not a whole number. It is because these are mixtures of what? Isotopes with different mass numbers. So it's more like they just get to find what? Averages. So this is how it is. So you say because they want you to state why. So you say because they exist. Because they do what? Because they exist as a what? As a mixture of isotopes. Mixture of what? Isotopes. Mixture of isotopes. I'll just say mixture of what? Of isotopes with different masses. With different mass number. With a different mass number. Different mass number. This is it. So we just get to find my average. This is the reason why you've discovered that most of those guys don't have my own numbers. Have you seen? This is it. We are done with that one. We now go to B3. I guess you are able to enjoy and you are able to follow me clearly and attentively. I believe you are able to enjoy, and most important thing is the understanding what I am teaching here. That is the good thing that I expect from everyone. Guess you've already followed me, you've already subscribed or followed this particular page, and a comment. Even as we are moving like that, you're saying following, understanding like that. So this is going to help you. You are writing your exams 2026, 2027, 2028, you are an internal candidate. Even as I'm teaching like this, you discover that even the paper you are going to find in your exams will just be the same as this one. So it is very important to understand everything that I'm teaching. And each topic I get to touch here, this is just an eye-opener. You need to study immediately you are done revising through this. So make sure you go through. We have done, this is falling under what? Under periodic table. Study through this. Isotopes, understand them. This one, define the term more concept. So make sure you study through that and understand. Define the term more. What is a more? I guess most of you know this particular question. We just say a more, this is the amount. So we say amount of what? Amount of substance. A more is the amount of substance that do what? That contain. So I'm going to say that contain same what? So I'm going to say that contain same number of particles. So same number of what? Same number of particles. Same number of particles. Same number of particles as they are. As they are what? Atoms. They are atoms in what we get to call 12 grams of carbon. 12 grams of what? 12 grams of carbon, or carbon 12 grams, like this. So that is a mole. This is what you need to understand. That is a definition of a mole. Then we go to this particular question that is here. Methane steam, have you seen? Methane steam reforming is the reaction between methane, which is CH4, and the steam. Water to produce hydrogen gas. Have you seen hydrogen? And carbon monoxide, which is like this. This is how it is. Now, the question that is here, they're telling us to say, construct a balanced chemical equation, including state symbols. Have you seen? Construct. So, this is methane steam reforming. Is the reaction between methane and steam to produce hydrogen gas and carbon monoxide. So you need to understand methane, this is a gas, CH4. It is like this. They've already told you that. So you say a gas there. But reacting with what? Reacting with this a steam, which is water in gaseous state. So steam, water in gaseous state, like this, which is also a gas. Giving us what? Giving us carbon monoxide, which is a gas, plus what? Plus water. So, I mean plus hydrogen gas. Here they are telling us hydrogen gas. Hydrogen gas. You do this. So there is nothing difficult here. How do you balance this? I guess you are familiar with this. Those of you that have done organic chemistry with me, I gave you these things. So you just need to put a 3 there. When you put a 3 there, hydrogen 6, 2 and 4, 6, 1, 1. So just needs to put a 3 there so that it becomes a balanced equation. So this is how you are supposed to go about these things, and this is how you need to answer them. Let us now proceed and look at other questions. So we proceed and let us now go to that was B. Now we go to C. This is C. Given that 80 grams of magnesium oxide reacts with dilute hydrochloric acid according to the equation. This is a particular equation that is given. I believe you are able to see it. This is a particular equation that you are given. So we are given this particular equation. Calculate the mass of magnesium chloride that was formed. They want us to calculate the mass of magnesium chloride that was formed there. We are given mass. We are taught to calculate mass. What are we going to use? We are going to use mass to mass calculation. I guess you've remembered mass to mass calculation. So mass to mass, you are given 80 grams of magnesium oxide. So we say magnesium oxide. we are going to equate it to what? Calculate the mass of magnesium chloride. So magnesium chloride, which is like this. Magnesium chloride is like this. So meaning that we are just going to compare the two, mass to mass. What is the mass for magnesium oxide? This is magnesium oxide like that. So this is capital O. You know, examiners get to be serious with these things. So what are you going to do? This is 1 times 16, which is equal to 16. We find the mass like this, 1 times 24, which is equal to 24. When you add there, you get 40 grams. So 40 grams of magnesium oxide. We are equating it to what? We get to equate it to this one that is here, magnesium chloride. You also do the same. This is magnesium chloride. You do the same. This is 2 times 35.5. We are getting the mass number. So this is equal to 71. Then with this is magnesium, just 1 times 24. So plus what? 24. What are we getting? 95 grams. 95 grams of what? Magnesium chloride. From the equation, so this one is here. So that is 95 grams. Then this one is given 80 grams of magnesium oxide. So 80 grams, I write it there. Then I equate to X because I want to find the mass of magnesium chloride. So this is what I'm going to do. X are cancelled. Those two are going to be cancelled. Then what is the next thing that I'm going to do? The next thing is to cross multiply. X times 40, that is 40x, which is equal to, I say 80 multiplies by, so 80 times 95. What is the answer? The answer is 7,600. Then here we are having grams, so I put grams there. Over 40, since I want to find the value of x, over 40. This cancelled. So x is now equal to, what is the value of x there? So that one, divide, so I say divide 40. Divide 40. What answer are we getting? We are getting what? What answer are we going to get there? So follow me clearly and attentively. So according to the calculations that I've done, I'm getting 190. Kindly follow me clearly. So 190 grams of what? Magnesium chloride. Like this. This is it. So I guess you've seen how I've answered this. So this is how you are supposed to answer it. So this is it. So when you multiply 80 times 95, just want to confirm that same answer. Then we get that same answer. We divide it by what? We divide it by 90 by 85. We divide it by 40. Divide the 40. What answer are we getting? 190. So kindly confirm with me. So make sure you go through these, all the calculations that are neatly done here. So they're easy to follow like this. Let us now proceed to B4. We now go to B4. B4 is telling us to say, so this one is falling under, just looking at this, is falling under oxides. So if you have no idea on oxides, you can't answer this question because it will look as if this particular question is difficult, but this question is not even what? Is not even difficult. So how then can we answer this particular question? So sulfur, zinc, and copper can react with oxygen to form oxides. They are forming oxides. We've got basic oxides, amphoteric oxides, acidic oxides. Those are oxides that we have. State the type of oxides formed by each of them. We've got sulfur. When sulfur reacts with oxygen, it gets to form a sulfur dioxide. Sulfur dioxide, you discover that is associated with something like it causes acidic rain, like that. So this is now to tell you that this one, this is called the acidic what? Oxide. Acidic oxide. Have you seen? Then we go to zinc. You know zinc, okay, zinc, you just need to know that it is amphoteric. Those of you that have gone through oxides, these are very simple to identify them, especially those of you that are my students. I explained these things and I believe you know them. We are just revising through and preparing ourselves for the exams. We've got the copper. So copper gets to form what we get to call basic oxide. So this is what basic oxide forms, a basic oxide. We are done with that. We proceed now to this question that is here. The question is saying that the question is telling us to say some salts are said to have water of crystallization. So water of crystallization can also be called water of hydration. So now the question is saying, what is water of crystallization and what is its importance? So what is water of crystallization? To make things very simple, this is just the amount of water molecules that are contained in a what. So I'll just say, let me be writing so that we get to move very fast. So I'll just say amount of what? Amount of water molecules. Amount of water molecules. So amount of water molecules contained. So that are what? That are contained in a what? In a crystal structure. So in a crystal what? In a crystal structure of a salt. Of a what? Of a salt. So this is the answer. This is how you need to go about that one. We now move on to an importance. Now, what is the importance of this same water of a crystallization? Water of crystallization help us in mineral identification. So you just say mineral what? Identification. So you just say mineral identification. This is it. So mineral what? Mineral identification. It helps us in mineral identification. It also helps us in stabilizing crystal structures. All those things are answers. So you can just choose from all those things. Let us now move on to the next question. I believe you are able to see how I'm answering this particular question. Some people will say I'm very fast, but I'm trying by all means to make it so simple. We are revising through. Whenever we talk over revisions, going through past papers, we are revising from what we've covered. We now go to this question that is here, B5. So B5 is telling us to say, state the collision theory in relation to chemical reactions. So they want us to state what? State the collision theory. What is this same collision theory? So when we are talking about the collision theory, you need to understand that the collision theory, this is a chemical reaction. So you are going to say that this is a what? This is a chemical reaction. I guess you are able to see this. So you say this is a chemical reaction which occurs. So a chemical reaction occurs when what? When reactants. So I'm going to say that when what? When reactants get to collide. So when reactants collide with each other, so I'll say with each, so with each other. So when they collide with each other, with what? With sufficient. So I'm going to say with what? Sufficient. So with the sufficient energy, when they collide with each other with sufficient what? With sufficient energy to produce new products. To produce. So you say to produce what? New products. This is it. So this is how you are supposed to answer it, just like this. Then we move now to this particular question that is here. Lumps of calcium carbonate reacted with 5 cubed centimeters of 0.25 molar hydrochloric acid to produce carbon dioxide gas. Water and calcium chloride. The following graph shows the volume of carbon dioxide gas that was collected in the chemical reaction in a given time interval. So this is it. This is what you are given. You are given something like that. So this is it. I guess you are able to see it. This is what you are given. On the same graph, draw another curve that would be obtained if powdered calcium carbonate was used instead of what? Instead of some lumps of calcium carbonate. So, have you seen? They are telling us to say now, if they get to use some powdered, instead of using these particles that are big like this. So, you need to understand that the larger the particles, the slow the reaction is going to be. But if we've got these small ones, you discover that the reaction is going to be very fast. So we're just talking about a fast reaction. So if it is very fast, this one is here, so this one is going to be somewhere here like this. This is how it is going to be, like this. So just follow this. So this is the thing that you need to put. This is how it is going to be. So if the question was the other way around, if they had to use these particles small, then they tell you that you use those ones. It is going to be down here very slow. So this is to show you that it is faster than that one. If we've got something here, it meaning this is the least. So this is it. That is, they're just telling you about what? They're just telling you about those rates, factors that gets to affect the rate of chemical reactions, all those things. That is the reason why, if you check this question that is here, explain how particle size increases the rate of chemical reaction. You discover that they increase the rate of chemical reaction because, so explain how particle size reaction increase the rate of reaction. So you say because, so they are telling you to explain. So you can start by saying, instead of starting with because, we can make it more advanced and say that increase in what? I'll say increase. So I'll say increase in here they are talking about increase particle size. So I will say particle size. So here I will say particle. So that is particle size. So particle size increase what? Increase the rate of what? The rate. So increase the rate of a chemical reaction. So increase the rate of a chemical. Increase the rate of a chemical reaction. So it increases the rate of a chemical reaction because, so because the smaller, so now this is the key point now. The smaller the particles, so the smaller the particles, the larger the what? The larger, so I'll say the larger the surface area. The larger the what? Surface area. So the larger the surface area and the chemical and the fast. So I'll just say the larger, the smaller the, because the smaller the particles, the larger the surface area and the reaction gets to be fast, and the reaction gets to be fast. Gets to be what? Gets to be fast. You can write this in your own language, but what I'm trying to explain is that if the particles are small, the reaction is going to be fast, because there you get to have a large surface area. So that is it, nothing much there. We proceed now to this question that is here. This is B6, so we are on B6. This is what? This is B6. B6, you study through all this. The diagram shows part of the periodic table. So it shows part of the what? Part of the periodic table. It shows part of the periodic table. Answer the questions using only the elements shown in the diagram. This is it. the letters do not represent symbols of actual elements. So they don't represent symbols of the what? Actual elements. Each element may be used once, more than once, or not at all. This is it. So you know that this is group 1, this is group 2, these are transition elements. Have you seen transition elements or metals? This is group 3, this is group 4, this is group 5. This is what we are given. Then the first question, let us now dive into the questions. So we now go to the questions. They are telling us to say which element is a meteoroid. Which element is a meteoroid here? You check. You need to do this here. So we start from where? We start from here, like this. This is how we get to move. Have you seen like this? So which one is a meteoroid? It is this one that is here. We are just given one. So it is just E. I put E there. So I just need to put E. Has chemical properties similar to the what? Strontium. So similar, or I would say, have you seen, has chemical properties similar to this. So one thing you need to understand is that if elements are in the same group, they get to have similar chemical properties. So this one is in group 2. So which one here is in group 2? This one is the one in group 2X. So there, the answer is just X. I'm using the knowledge that I have on the periodic table. This question forms an ion which gives a red-brown precipitate on addition of what? Aqueous ammonia. So what answer is that? That is what we get to call ion. So the answer is just Z. Like this. So if you check where Z is, ion, check your periodic table very well. Ion is somewhere here. This is where we get to find ion. This question that is here forms a stable ion by gaining 3 electrons. So by gaining 3 electrons, those that gains 3 electrons are in which group? Group 5. Check here. Group 5, we are just given 1, which is J. So the answer there is just J. Because gaining 3 electrons, only group 5 elements gain 3 electrons. Is extracted from hematite. Sure. This is ion. So ion, where is ion? I had to mention it somewhere. So Z, like this. Is used in galvanizing. So galvanizing, we get to use what? Zinc. So where is zinc? You check zinc, somewhere here. Q. So you put your answer there as Q. So that is it, and that is how you are supposed to answer these questions. The same way I'm answering, this is how you are supposed to answer them, even in your exams. So you just need to follow this same way of answering questions. We proceed. We now go to this one that is here. We now go to which one? We now go to B7. The letters XYZ, W, X, Y, Z refer to 4 different metals found in nature. The letters used are not actual symbols of metals. The following information was obtained. This is it. Have you seen? So here, this particular question is falling under a topic that we get to call metals. Under this, you need to understand the reactivity series. So if you don't have much information on the reactivity series, then you may find challenges in answering this particular question. Have you seen? W reacts with this chloride and X in it, no reaction. Why? Because the chances is that maybe this one is more reactive than that. These are one of the reasons. Because if this one cannot replace that, there will be no reaction. So meaning that X is what? X is more reactive than Y. So I mean W. X is more. So I'm going to say is more reactive. So I'll tell you is more reactive than W. This is the case. When these two react, have you seen? We are able to notice something here. When this react with that, a reaction is there. Have you seen? So this one has managed to repress X. So meaning Y is more reactive than X, is more reactive than X. This is just to help me gather some sense. Then after this, I answer the questions very fast. Have you seen? If you check through this, this is also to tell you something. So this is to tell you that Z is more reactive. Z is more reactive than W. Z is more reactive than W. Have you seen? Then here we said X is more reactive than W. Here we are saying Z is more reactive than what? W. Then the last one, have you seen? Z is more reactive than W. Then you are able to even here, have you seen? The Z plus X, no reaction. So this is to tell you X is more reactive than what? W. X is more reactive. I mean, X is more reactive than Z. So this one is more reactive than that because this has failed to replace that. Then the question here, they are telling us to say, list the metals according to their ascending order. So we start doing what? Ascending, going up. Least reactive to more reactive. So which one is least reactive here? So you discover that here we are saying that this one, X, is more reactive than Z. Even Z is, X is more reactive than W. Even Z is more reactive than W. This is to tell you something that this one will start with W, which is least reactive. Then you are going to observe X is more reactive than Z. Then here they are telling us to say that X is more reactive than W, Y is more reactive than Z. So meaning that here when I put a Z here, then X must follow because X is more reactive than Z. And Y is more reactive than X. So Y gets to follow there. So the one that is more reactive is Z. I know most of you may get to find some challenges understanding this particular part, but the best thing is go through our exam questions. You discover that these are very simple. And I've told you, study through these notes. After this, I know most of you get to have these things in your books, so study through them. Let us move to B. B, identify the type of chemical reaction that has occurred. All these, we are just talking about this one is more reactive than this one is able to displace this. So it is what we get to call a displacement reaction. So displacement what? Reaction. This is it. So displacement a reaction. Then they are telling us to say that using the letters X, Y, Z, identify a metal which will react very vigorously with cold water at room temperature and pressure. So here it is only what? Y. So you just say Y here. If you check where Y is more reactive than X, so meaning this particular Y is more reactive than all these. Have you seen? So this is it, and this is how you are supposed to answer these questions. So we jump to B8. We are almost done. I guess you are enjoying this. And those of you that are interested in starting up your tuitions with me, this is my WhatsApp number. You can WhatsApp me. I help you get that distinction that you want. So this is my WhatsApp number. +26 0971 066747. Ammonia is manufactured industrially in the Haber process. State the chemical formula for ammonia. This is the chemical formula for ammonia, isn't it? As simple as that. You don't need to waste time there. They are telling you to say here, is ammonia an element, compound or mixer? Give a reason for your answer. This one that is here, is it an element, compound or mixer? This one is ammonia. You say ammonia, so this is what you need to do there. Ammonia is a compound. Is a what? Is a compound because it is formed, because it is formed, it is formed by chemical combination, by chemical combination of what? Nitrogen, of nitrogen and what? Hydrogen gas. So you write in words. So hydrogen. Have you seen you've got nitrogen and hydrogen? So this is it. Here they are telling you to say, write a balanced chemical equation that takes place during the Haber process. This one you just need to know it. So I'm going to write it like this. This is how it is. 2 there, a plus 3 like that. This is a reversible. So you write it like this. This is 2NH3. I guess you know this one. This is how it is, and this is how you are supposed to understand it. So you know that everything is gas. Gas there, even this one gas. Just like that. Then they are telling us to say this particular question. They are telling us to say, state any 2 conditions necessary to minimize the yield of ammonia during the Haber process. It's more like some conditions necessary for this whole thing to occur. You need to have what we get to call a catalyst. The catalyst must be present. What is the name of this catalyst? Catalyst, so the name of a catalyst that should be there, this is ion. Catalyst ion. We can also consider pressure. Pressure should be around. So pressure, I'm just giving you answers. So you can go with this one, then 2, you can look at pressure of what? Pressure of, I would say pressure should be 200. So 200 to what? So I would say 200. So pressure of 200. So we say pressure of 200 to 300 atm, like this. The other thing, we can consider a temperature. So we can also consider temperature. These are things that you need to understand. Temperature of what? 450 to 500 degrees Celsius. So this is how it must be. So 3 things. I've given you 3 things. You just pick from this. You say a catalyst should be used, which is ion, pressure of 200 to 300 atmosphere, a temperature of 450 to 500. So these should be present. So this is how you need to answer. Let us now dive into the last question. This is the question that I'm going to end with. I guess you've already followed me. You've subscribed to this channel and you've put a comment there. And do not forgetting to like this particular video so that it gets to be recommended to other people. This is organic chemistry. Immediately I'm done with this, study through this particular topic. This is one of those important topics that a person needs to understand. The following are organic what? Compounds. These are organic compounds. Have you seen? These are what? Organic compounds. Which of the structures A, B, or C can decolorize aqueous bromine? So here we are just talking about some tests. So when we are talking about decolorizing aqueous bromine, we get to talk of alkenes. From all these compounds that are given, which one is an alkene? Alkenes get to have double compounds. And one cardinal thing is that alkenes, these are hydrocarbons. So an alkene is a hydrocarbon. So in this case, hydrocarbon, here, just hydrogen and carbon atoms. So it is just what? It it is just A. So using the letters, I put A there. Is used as a disinfectant. So which one is going to be used as a disinfectant? Alcohol. Which one is an alcohol here? This one, alcohols gets to have an hydroxyl group. Hydroxyl group is this one. Have you seen? But here, this one, it is having something like this. Have you seen this last part? This is to tell you this is an acid, this is an alcohol. So that is just a B. You are done with that. We now go to this one that is here. Simple questions. So identify any two structures that can combine to form a compound used in making perfumes. Making perfume, esters, esterification. So what two compounds here are we talking about? When an alcohol reacts with a carboxylic acid. So we're just talking about B and what? C. So B and C. So just say B and C. These are simple questions. I guess you are even able to see. We now proceed to our last question. I guess this is the last question, this one here. They are telling us now to say, draw a disparate structure to show the compound formed in the reaction. So B and C. When B and C react, so B is here. To make it short for you to understand, this one is B. Have you seen? This is B, isn't it? Having how many carbons? 1, 2, 3. So 3. C3. H how many? 1, 2, 3, 4, 5, 6, 7. 7 like this. Then I put O, H like this. This is it. This is B. I write it here so that you try to understand this. So this is C3, H, 7, O, H. Reacting with the C. See this one that is here. I mean 1, 2. Have you seen 1, 2? C2, H. Have you seen C2, H? 1, 2, 3, 4, 5. 5. Then COOH like this. So this is it. I write it here. I'm not mentioning names here because I don't want to confuse someone like this. Then they want now a disparate structure of the compound that is going to be formed. So a compound that is going to be formed, you need to understand that this one drops the OH. Here we drop just H like this. Then we put them together. So how then are we going to do it? C2, we start with this one. H5, CO, here, OH gone. Here, H gone. I'm remaining with that O. Then I put C3, H, 7, like that. So this is now a structure that I'm going to put this one. So C, my hydrogens 5 like this. 1, 2, 3, 4, 5. This is how it must be. So this is how it must be. Then here I put C double bond O like this, another O. Then C3, 1, 2, 3. How many hydrogens? 7. 1, 2. This is not a double bond. I don't want to confuse someone like this. So this is just a structure that they are looking for. Have you seen? This is just a structure that they are looking for. They haven't said we name it, we put my names. No, I can end up confusing someone. I've done a lot of videos under organic chemistry. So this is it, and this is what I wanted us to go through. I help you revise through some of these questions. So we've come to the end. I guess you've revised through and you've seen how to answer exam questions. Those of you that are interested, I get to offer tuitions at an affordable fee. You WhatsApp me on this number. So for those of you that are in Zambia, it's only 100 kwacha per subject. So if you're doing science, which is a combination of physics and chemistry, you just pay 100 kwacha. So this video is public. The people that are under my online lessons and those of you that are not, I guess we've all benefited from this. This is the reason why I want you to share, like, comment, share to your friends. Thank you so much, and I believe you've revised through. I know I was a bit fast because I wanted to kill time, but I believe you've understood. So you need to know most of these things. Bye bye.